Welcome to our workshop. So I'm TF from Taxa Network, and also here's our team member Chris. So in this workshop, we'll be introducing how to build what Taxa Network does, and in what scenarios should you use Taxa Network, and how do you build a privacy-preserving and computational powerful Web3 services. Okay, so the problem that Taxa Network is trying to solve. I know you have heard a lot of projects that are focusing on solving the scalability of the blockchain. Well, Taxa Network is not addressing the network performance in terms of TPS, but Taxa Network is focusing to provide a stronger, a more powerful version of smart contracts. And we are focusing on the performance of individual smart contracts, which in terms are those aspects. So here's a comparison between the Web3 applications and Web2 applications in some aspects. And I know this is not a very fair comparison because the main breakthrough of Web3 is on its trustlessness. Well, on the performance, it suffers a big disadvantage. For example, the time and space resources you can use in an individual smart contract is very limited because of the limitation of gas fee, block size. And also the functionality are very simple and basically focus on crypto and the very basic business logics, while lacking of some rich functionalities due to that is mainly due to the consistency requirement. And also because of the consensus mechanism, we have to wait for the block confirmation. And also, it's very difficult to protect your privacy on the blockchain. So we have paid a very heavy price to achieve the trust. And Taxa Network is aiming to solve the performance and privacy issue for the individual smart contracts. And our solution is to build a layered architecture for the dApps. And by moving your business logic from on-chain to off-chain, we don't have to be restricted by the consensus mechanism of the smart contracts. While we are using the trusted execution environment technology, which is a privacy computing technology, we can guarantee the application's trustlessness in terms of confidentiality and also integrity. So in conclusion, we put them off-chain, and so we will have a higher privacy, and we can build interactive applications. Well, by using the TEE technology, we can guarantee the integrity and the confidentiality of your application even without the blockchain. So here's the idea of a layered architecture of the future, envisioned by us of the future applications. Today, you already see a lot of middleware infrastructures acting a very important role in our dApps, for example, the oracles or the IPFS. Well, in the vision of Web3, we are still lacking one very important cornerstone, which is computation. Today, they are most built on the layer one blockchains. Well, to support more meaningful, more meaningful applications, for example, like games, interactive games. We do need an infrastructure that can do some high performance computation while keeping the user's data privacy, and Taxa Network is aiming to becoming this role. So as you can see, we put the computation from in the middleware Taxa Network. Well, only when you need to generate a finalized state will you need to generate an on-chain transaction. Or in other words, the relationship of Taxa Network to a blockchain is like a backend to a database. You only need to write the finalized state on-chain, while the computation can be done completely off-chain and protected by the privacy computing technologies. And let me introduce you the tService, which is the application running on the middleware Taxa Network. tService is short for trustless services. And it's a bit different from the on-chain smart contract. First, it's interactive, based on a request-response-based protocol. And we also wrapped it into a RESTful API, just like calling a Web2 service, but it's trustless, yeah. And also, due to the nature of Taxa Network, we are not a layer one blockchain. We are stateless. And but we provide a very convenient way of interacting with layer 1 blockchains. Third, because we are off-chain and using the privacy computing technology, we guarantee your data privacy in your applications. And the privacy data during transmission and during computing are private unless the developer choose to reveal it. So it's opt-out privacy. So on the development wise, you can think the tService like a type. You can think Taxa network like a type of oracle, but instead of feeding the internet data, we feed you the result for your entire business logic, and which guarantee the data privacy and the computing performance in terms of the computing and the storage resources. So we migrated an Python interpreter environment inside the trusted execution environment. Currently, we are using Intel SGX, and you can develop the trusted applications using one of the most popular language, which is Python, service-oriented development framework, and also supporting a lot of third-party libraries. So the example, let me begin with our Hello World example on Taxa network, which is called the millionaire problem. It's one of the most fundamental privacy computing program proposed by Professor Yao Qizhi. And the problem is, assuming there are 2 millionaires, they want to know which of them is wealthier without revealing their actual worth. So in an ideal case, you want a judge, and both parties can trust it, and both parties can guarantee it's honestly executing the business logic and while keeping their data privacy. Blockchain is designed for trust. However, it's very difficult to implement on today's architecture due to privacy issue. Well, in our case, on Taxa network, because by default we can guarantee the data privacy, you can implement such a Hello World application in a very simple architecture. Just like imagine you are developing a centralized application. The 2 users don't trust each other, but they do trust you, and they send their privacy data to the application, and the application will serve as a judge, tell them the result. It's very straightforward. On Taxa network, we execute those applications inside the security enclave, so you can guarantee 3 things. First, you can always guarantee the Taxa node is honestly executing your code, and secondly, you can guarantee the integrity. You can always guarantee the node feed you back the correct result without tampering. Thirdly, it can guarantee the data privacy during execution. And the way user interact with Taxa network is based on a interactive protocol. And all the entrance of the tService are marked by a URL, a Web3 URL, just like the IPFS one. And using multi-hash, it indicates the hash of your tService code. Just like because is compatible with IPFS, you can directly serve the code on IPFS. And both users will establish a secure connection with the enclave in the Taxa node. And just like you can imagine, it's like an HTTPS handshake. And the node, the computer provider, serving as a middleman, he cannot. Although he's a service provider, it cannot read any private data submitted by user or during the computation. And the code for solving the millionaire problem is very simple. So in our case, we have 2 entrances. First, both users submit their worth, and the function is called submit value. And you write a Python function. And secondly, after both users have submitted their worth, both millionaires send their worth, and they will call another function called getResult, and we directly feed user the result by very direct business logic. And all those code are running inside the security enclave, which means the node will not be able to read or tamper the computation. And you just feed back the user result, and both users will be able to decrypt the result on their client side. And there are several. When you are developing tService, there are several key concepts First, request and response. They are in JSON format. They're carrying both confidential and non-confidential data. And there's a certain field called data, which is encrypted, contains the encrypted data. And only the user and the secure enclave have the decryption key. Any third party, including the service provider, will not be able to decrypt them. And the IP ID means the hash of the code. Is the only identifier of the code. So when two users are calling the same IP ID, we can guarantee they are calling the same tService. And also URL is consistent with a Taxa header and the code of the hash and the function. And the user identity is represented by a ECDSA key pair. And later you can find them on our developer documentation. And also Taxa network support a temporary storage mechanism called session. We keep them by default 7 days by default. And you should not rely on it will be available during your tService lifecycle, but you should not use it for permanent storage. And for the Python developed framework, we call that Pyxa, and which is in short of Python plus Taxa. That is a Python runtime environment we migrated inside Intel SGX, and it's derived from Python 2.7. And in addition to Python 2.7, we have added some crypto and blockchain library support. So for example, you can directly generate signatures, generate wallets inside the Python code. Well, we also, and due to the nature of tService, we also removed the file system, network, and process access. So it's pure computation. And also, we are keep expanding our framework, adding vertically to add some third-party libraries to support more functionalities on Taxa networks. And I'll briefly introduce how you interact with a layer 1 blockchain from Taxa network. Chris will later show us the details. But the basic idea is very robust and simple. The idea is generating a signature. So the problem we are solving is how can we trigger a transaction on layer 1? Or in other words, how can we verify whether a result is generated from Taxa network or is a forged one? And the solution is we generate the signatures inside the tServices, inside the security enclaves. And later we could verify such signatures on Solidity using EC recover function. And then you can authorize transactions. For example, assuming there are two players want to play a poker game. Poker game is the multiplayer poker game is not very easy to be built on layer 1 because it should be interactive, and also you need a certain level of privacy. Well, on Taxa network, you could just build in a very straightforward business logic. Well, after the game is over, the Taxa network could generate a signature, and the winner could submit that signatures to Solidity smart contract, and the Solidity smart contract can verify that signature whether it's coming out of Taxa network and execute the transaction. For example, who will take the chip on the table? And we provided a library called Pyxa ECDSA, which is compatible with Solidity's EC recover. And because of our privacy preserving feature, the user could safely submit their private key into the tServices, and the tServices will generate the signature for them. So some ideas of building on Taxa network. First, game and NFT are always a hot topic, and especially for the games. You know, today's games are suffering from some limitations when you are building on blockchains. For example, you may easily build a chess game on blockchain, but if you want to build a card game, which requires interaction and requires a certain level of privacy, it's much easier to be built on Taxa network. And also NFTs. NFT-related features. For example, some developers are building some gamification type NFT that you know. For example, in the previous East Global, there were people building the Prisoner Dilemma game on Taxa network and combine that with NFTs. Yeah, and also collaborative computation and DeFi privacy and also identity. For example, how do you authenticate a user without revealing his details? It's like the tService will tell a yes or a no, but the user won't need to reveal their actual privacy data. Yeah, and here let's begin with a demo. So we have two demos. First demo is about how you set up an SDK and execute some basic Taxa network request. Second demo is how you authorize layer 1 transactions. So Chris? Okay, so first we connect to our node. And to send a Taxa network, to send a request on Taxa network, you can set up the Taxa SDK on our documentation. And there are three very simple steps to send a request. First, you import our SDK in your local Python code. Notice, although it's Python, but it's running on your locally on the SDK. And the second step is to generate your identity, and we already support a function by initiating a request object. Yeah, and if you're first time using this, the SDK will automatically generate a key pair, elliptic curve key pair representing the user's identity. And go ahead, we call the send function, which will carry the Python code with it. By the way. So due to the nature of Taxa network, there is no deployment necessary for the tServices. And on protocol-wise, the user is required to carry your tService code inside your request to the node. And the node will hash your code and find out the app ID. And engineering-wise, our node will cache the code for the tServices. So so you don't actually need to submit every time, but by default you can just submit the tService code as a parameter, and you call the send method to send the request. Yeah. So when sending the request for the first time, the Taxa network will do three things. So first, it's called a remote attestation. That means your computer will establish SSL type connection with enclave in the Taxa node. So after the handshake, they will do the Diffie-Hellman key exchange, and they will negotiate an AES 128 key, communicating directly between the user and the enclave. No one else in the world have that key. So yeah, it's basically like a SSL handshake. And all your traffic is encrypted by AES. And as you can see, there are some debugging data, but the request contains a status and a response. And also, most importantly, there is a data field, and which contains the secret data in your request, which is encrypted by AES. And yeah, and also there's a response. Well, response will also be carried, and you can decrypt them and process them in your Python code. And next, Chris will demonstrate how do you generate a signature and verify it on Solidity. Go ahead.
So this contract that we just executed, what it is basically just it's this right here. It calls this ECDSA signing key.eth sign, and it generates a signature, and it's signing this message up here that's just A, B, C, D, E, F, G, and then here's my private key. And so the signature is returned, and then it's added to the response. And so if you look up here, the decrypted data, this is the response from the Taxa server that's been decrypted. And so right here is our signature. And so what we're going to do is verify that this is a valid Ethereum signature by, we have this Solidity contract that has been deployed to the testnet. And it's simply just, we have this is valid signature. Well, down here, it's, where is it? Is valid signature, yes. So it takes two arguments. The message, the original message, which is just A, B, C, D, E, F, G. And then a signature, which I'm going to paste in here. and then we can call it, and the return value is true. That's because the signature is valid.
Yeah, so the key is first, inside the Taxa tService, you use the ECDSA library to generate a signature. And it is safe for the user to submit a private key inside the tService because it's entirely running in the security enclave. And after you generate a signature inside the tService, you output the tService inside the response. And if you want to verify the signature, you call the EC recover in Solidity, and and the format is entirely compatible. So the EC recover will tell you whether the message is legit generated from the Taxa tService. So that's the way you authorize a transaction on layer 1. Yeah. Okay, and here are some useful links. So for the developer documentation, go to docs.taxa.network. And also, you can always go to our booth at the first floor. We are happy to answer all your questions in your development. And also, our engineers will be on Discord to answer your questions. So yeah, please mark those link. And happy hacking. Thank you, guys.